Assalamualaikum and good day. We would like to present about error analysis, a comparison between distance and discrete least square. This is our teammate Muhammad Fadlizal Ikram bin Rushdan and I Norman Hakimi bin Abu Bakar Azhari from CDCS 24940. So first and foremost, our introduction. For this study, we used a leaf to figure out how long it was. So the distance formula and the discrete least square method were the two approaches we used. We used both techniques to determine the length of the charting points along the leaf's edge on graph paper. So the least squares approach estimated a smooth curve, whereas the distance formula measured segments of a straight line. And to determine which approach was more accurate, we evaluated the findings using relative error and percentage relative error. This emphasizes how crucial it is to select the appropriate numerical method depending on the type of data and the level of precision needed.
Now, for the problem statement, the first one is estimate the distances between objects, for example, leaf, using graph paper and numerical methods. The second one is fit a mathematical model to the observed data using the least square method, thereby improving the analysis of the measurements and reducing the impact of measurements error. So now, what is the objective of this report? So, the first one is to measure distance between objects using graph paper and record their coordinates accurately. Second one is to apply numerical methods including direct distance and least square for estimating this distance. The third one is to analyze and compare measurement errors to evaluate the accuracy and reliability of each method. Scope and limitations. The first one is direct distance. The direct distance method is a straightforward approach to calculate the straight line distance between two points, often in a coordinate system. The second one is least square method. The least squares method is a mathematical technique used to find the best fitting curve or line to a set of data points by minimizing the sum of the squares of the difference between the observed values and the values predicted by the model. Implementation. Direct distance. Suppose you have 2 points A, x1, y1 and B, x2, y2. The direct distance d between this point is given by d equal to z x2 minus x1 square plus y2 minus y1 square. Substitute the coordinates into the formula to get the distance. Now, the least square method. A quadratic model given fx equal to a0 plus a1x plus a2 x square. Use the data points to set up a system of equations based on the model. Arrange the data in matrix form to solve for coefficients a0, a1 and a2. The goal is to find the arc length of the leaf using the formula integrate AB z1 plus f prime x square. Result of this report. The first one is direct distance. This is the graph of the leaf that is for the data. So first we sketch the leaf in the graph paper. After that, we will find the x and y, and to find the distance, we will use the equation that we discussed before. So then we will get all the distance between 2 points, and finally we will adding up all the distance to get a total of distance, which is 18.2552.
So next, least square method. So next we use the least square method, and we got 4 sections, A, B, C, and D. And first and foremost, A section, we got sum of x squared, sum of x to the power of 3, the sum of x to the power of 4. And the answer of the sum we put into the matrix. And next we got the sum of y, the sum of times x and y, and the sum of x squared times y. And we got a0, a1, and a2, and we put into the function of f, a0 plus a0x plus a0 plus a1x plus a2x squared. And we differentiate that function, and we got 1.4598 plus 0.1585x. And the function, the derivative of function we put into the arc length formula, and we got 4.8950. So the B section, we got the sum of x, the sum of x squared, x to the power of 3, x to the power of 4 for the first matrix. And we got the sum of y, sum of times x, y, and y, and the sum of x squared and y. And we put it into the matrix, and we got a0, a1, and a2. And the answer we put it into the function of x, and with derivatives, and we got 1.3173 minus 0.2338x. And we put it into the formula of the arc length, and we got 12.5097. So next is the C section. We got the sum of x, the sum of x squared, the sum of x to the power of 3, the sum of x to the power of 4. And we put it into the first matrix, and the second matrix is a0, a1, and a2. And the next matrix is we got the sum of y, the sum of times x and y, and the sum of times x squared and y. And we got the a0, a1, and a2, and we put it in function of x. Is it the a0 plus a1x plus a2x squared. And with derivative that function, we got negative 6.3018 and plus 1.1958x. And we put it into the arc length formula, we get 4.5517. So last but not least, this section. This section, we got the sum of x, the sum of x squared, x to the power of 3, x to the power of 4, and the sum of y, the sum x times x and y, and the sum of x squared times y. And we put it into the least square method, and we got the a0, a1, and a2. And the a0, a1, and a2, we put it into the function of f, and with the derivative of the function, we got negative 0.4131 plus 0.1434x. And the derivative of function, we put it in the formula of arc length, and we get 4.4725. So by the least square method, we want the perimeter of the leaf, so we got 26.4289 centimeter. So from the direct distance and by least square method, we want to analyze what is our error. So the actual distance, we got 34.7 centimeter, and the method we use approximate distance. We use the formula to our direct distance and least squares to get our distance for the analysis, and we use absolute error and the relative error and the percentage relative error. So for the direct distance, approximate distance, we got 18.2552, and absolute error 16.4448, and relative error 0.4739, and percentage relative error we got 47.39%. And for the least square we got 26.4289 for approximate distance, and absolute error 8.2711, and next for the relative error 0.2384, and last but not least percentage relative error 33.84%. So after we analyze to know about the error, and we discuss about how we get and why. So the exact length of the leaf, which is the measure with the string, we got the 34.7 which is the exact value, and the distance formula result is 18.2552 centimeter, and the relative error we got 0.4739, and the percentage relative error we got 47.39%, and for the least squares method result we got 26.4289, and the relative error 0.2384, and the percentage relative error we got 23.84%. And from all the result, the approximate value is least squares method, which is 26.4289 centimeter, because of the percentage relative error is 23.84%. So the least square method gives a result much closer to the exact value. So lower relative error means a more accurate and reliable estimate. This shows that the least squares method is better suited for estimating curved shapes like a leaf.
Conclusion of the report. The study demonstrates that employing graph paper in conjunction with numerical techniques facilitates accurate distance estimation. Although results require precise marking, the least squares approach proved more accurate. All things considered, this technique increased measurement reliability in the real world. For the next one is reference. So all of this is our reference for the report. That's all from us. Thank you.